So welcome to module 2 of basic automobile technology. Here we will be talking about the engine. So module 2 is understanding the engine. So engine is heart of the automobile. Like heart keeps pumping, similarly the engine also keeps going up and down. It also keeps pumping, you can say, in one way. Until the time engine is going on, the car is alive, your automobile is alive. The time engine stops, the car stops. So it's just like heart of the engine, heart of an automobile. So to understand the engine, we'll divide it into four parts. One is what is ICE? Why we call it as internal combustion engine. Second is the difference between petrol and diesel. So what is that difference and how both work actually? Third is two-stroke versus four-stroke engines. And fourth is major engine components and their functions. And in the end, we will have a knowledge check. So what is an ICE engine? Before internal combustion engine, there used to be steam engines. So can anyone tell me where the combustion used to take place in a steam engine? The combustion was happening. There was a boiler filled with water, and the combustion, the coal was burnt to heat the water, and because of that heat, steam was created, and steam used to push the cylinder. That actually used to power. So the combustion was happening outside the engine. Now here it is internal combustion engine. That means what? The combustion is happening inside the cylinder, right? So the definition of a ICE engine is an engine that burns fuel inside the cylinder to create motion, right? So ICE is an internal combustion engine. It is heart of the vehicle. It converts fuel into mechanical energy. It is creating movement now. So fuel to, or rather chemical energy to mechanical energy. Then there are two types of engines when we talk about the fuel type. The two types of engine, one is petrol and the other is the diesel. So we'll talk about the difference between both. So how a petrol engine works? So first of all, we'll talk about petrol engine. So like we have food, what we do? We do intake, then we chew it. What we do? We compress it, and then we ingest it. It goes into our intestine. Intestine compresses it more, and it takes out all the energy from there and powers our body. Now what happens? There is a waste. So waste is expelled in the morning. So how many strokes? Four strokes. In intake, then compression, then power, and at the end, exhaust. So same four strokes are there in the engine also, whether it is petrol or whether it is diesel. Both the engines have four strokes: intake, compression. So in petrol engine, what happens? What is the difference between petrol and diesel? In petrol engine, during intake stroke, air and fuel mixture goes inside the cylinder. Remember this is very important. When you are doing intake, the air and petrol, the fuel mixture is going inside, right? You can see it here. Air fuel mixture enters the cylinder. Okay. Then when air fuel mixture enters the cylinder, Then we compress it. Now the second stroke is compression stroke. So mixture is compressed by the piston. It's going up. You can see here, so much of air fuel mixture was taken and it was compressed and only this much is left. Okay. So this is also called as compression ratio. We'll talk about it later. Then when air fuel mixture is compressed, now what happens? It's highly compressed air fuel mixture inside, high density. Now in petrol engine, what happens? There is something called a spark plug. As the name suggests, it gives spark, right? Because the fuels have different qualities, characteristics, or rather properties. For petrol to burn, we need spark. Whereas for diesel to burn, we need to inject into high temperature. It will catch fire automatically, right? So that is the difference, and that is why there is a difference between both the engines. So here it is petrol engine, there's a spark due to spark plug. And as soon as there is spark, what happens? There is a highly compressed air fuel mixture inside. What will happen if you give a spark? It will blast, right? And once it blasts, because there is no other space to go anywhere, the energy cannot go anywhere else. So what happens? It pushes the piston down, and that actually creates the power stroke. I hope I'm clear. Intake air fuel mixture gone inside, then we compress it, then we give a spark. Because of spark, there's a blast, and the blast pushes the cylinder piston down. Blast inside the cylinder, and piston goes down, because of which the power stroke is created. And now once the piston has gone totally down, now what happens? There is a burnt gas inside. Air fuel mixture is burnt now. Now we need to expel it. We have to send it out. And that leads to exhaust stroke. So exhaust gases are expelled. Now how this happens? This happens with the help of intake valve and exhaust valve. During intake, the intake valve opens, that allows the air fuel mixture to come inside. Then during compression stroke, both the valves are closed, intake as well as exhaust valves are closed. Then during power also, both are closed. As soon as the exhaust starts, the exhaust valve opens, intake valves remain closed, exhaust valve opens, and the burnt out gases are expelled out. You can think valves like nose. We breathe in and breathe out. The same function the valve does. So how the diesel engine works? We have seen the petrol engine. Now let's see how the diesel engine works. Same four strokes, but the difference here is, in diesel intake stroke, only air comes inside from the intake valve. What I said in the petrol engine, that the property of diesel is, and for petrol you need spark, but in diesel you need high temperature. That's all. If you inject diesel in a high temperature, it will catch fire automatically, right? So what we do here is we intake the air inside in the intake stroke, and then we compress the air, right? So when you compress the air, what happens? If you have filled air using that pump in football or your cycle, if you touch the bottom of the pump, has anybody touched it? If you have touched, you must be knowing it gets hot, So when you compress anything, it gets hot. So here the compression is very high, because of which the temperature inside the cylinder is very high. Right? And now the diesel is injected. Instead of spark plug, here there is a fuel injector. Right? If you look here, there is a fuel injector. In petrol engine, there it was spark plug. Now here it is fuel injector. So as soon as the diesel enters into this hot air, the same thing happens that happened in petrol. There's a blast. Now when the blast happens, what will happen? It will lead to power stroke, pushing the piston down and giving the power to the wheels. And then the last stroke, that's the exhaust stroke. Now the burnt out gases need to be expelled. So that is what happens in the exhaust stroke. I hope I am clear with all the four strokes. So major engine components. Now the major engine component is, first of all, this is engine block, right? If we look at the whole thing, this is called as engine block. And the round, this holes that you can see, these are cylinders actually. So this engine has 4 cylinders. It's a 4-cylinder engine. Inside this, piston moves, so that is where the power is generated. Okay. So here you can see the pistons, right? So these are pistons, right? So these are pistons and these are rings. You can see there are various types of ring, 4 types of ring. And in between there are cuts. Why the cuts are there, anyone? This is called as oil ring. You can see the shape of these rings are different, right? But these are uh, normal rings with cut. So these cuts are actually for oil to come up, and these oil ring actually spread the oil. They lubricate the cylinder and cylinder, so that the friction is reduced and the wear and tear goes down. Next we have crankshaft. So crankshaft, you can take it like a cycle pedal, you know. So one goes up, the other comes down. When this goes down, the other one comes up. The same type of construction as for crankshaft also, because this actually leads to the circular motion. Right? The up-down motion is converted into rotary motion. So because of that, the construction is the similar, just like the cycle pedals. But because there are 4 pistons, 4 cylinders, so in one power is happening, in one intake is happening, in one exhaust is happening, in one compression is happening. So that's why the location of all the 4 is in a different way. Next is connecting rod. So connecting rod, now this part of connecting rod is fitted to crankshaft and this part is fitted to the piston. So on top of this you have piston and this is connected to connecting your crankshaft, and that is why it is called as connecting rod. It connects piston to crankshaft. Then we have camshaft. Camshaft, as you can see, these are cams. These are egg-shaped parts here. So they actually open and close the valve based upon the stroke, right? And this is called as timing belt or timing chain. And this is ultimately connected to crankshaft. So camshaft is connected to crankshaft with the help of timing belt. And camshaft does the work of opening and closing the valve, timing the opening and closing of valve. That is being done by the camshaft. Because if the timing is out, the engine performance will go down. The engine can misfire. Sometimes you must have heard the sound fart fart happening. It is because of the mistiming actually. Then we have valves. So these are actually valves, right? Here you can see two valves. Generally in cars nowadays we have four valves. There are cars which have three valves also, right? So two for intake, one for exhaust, or one for intake, one for exhaust, right? It depends upon the manufacturer and their technology. So we have two types of valves, intake and exhaust. And like I said, the valves you can consider like nose. Breathe in, breathe out. So intake is breathing in, exhaust is breathing out. Spark plug. So spark plug, like I said in the petrol engine, this actually gives the spark. Here there's a high voltage wire that is connected to this from a coil. And now we have SDLI's smart distributor-less ignition system. So every plug has a coil. So from the coil, you have a high voltage current that comes here, and there's a spark. Spark will happen here in between this point and this point, and that leads to something like when you light your gas stove, no? You use the lighter, so there's a spark. The same kind of thing happens here also. Fuel injectors. Now don't confuse. There are fuel injectors in petrol also, and there are fuel injectors in diesel also. In diesel, the fuel injectors are directly fitted onto the head. They inject the fuel directly into the cylinder. Whereas in petrol, the injectors inject the fuel before the valve, on top of the valve, inside the intake manifold. What is intake manifold? We will talk later. Right? So there are fuel injectors in both petrol also and diesel also. In petrol, they inject the fuel outside the cylinder, whereas in diesel, they inject the fuel inside the cylinder. Now, the difference between two-stroke and four-stroke engine. In two-stroke engine, as the name says, they're just two-stroke. Compression and power happens in one stroke itself. Right? Compression and then power happens. There's a spark and power happens. Similarly, exhaust and intake happens in one stroke. Right? So because intake and exhaust happen in one stroke and there is a compulsion of mixing oil with the fuel. So this has more of pollution, and that was the major reason why two-stroke engines were discontinued in most of the vehicles now. You don't find two-stroke engines. Whereas in four-stroke, I've already told, four-stroke engines have four strokes, separate stroke for intake, compression, power, and exhaust. Chargers are intercoolers, right? Turbochargers generally used to be with the diesel vehicles, but now you can find turbocharged engine in petrol also. So turbochargers, as the name suggests, what they do is they charge the air actually. How they charge the air? There's something called as turbocharger. So turbocharger, if you look here, what happens? There is a turbine here and there is a fan here. So there are exhaust gases coming out from the engine at a very high pressure. The exhaust gases that come out of the engine are at a very high pressure. So this exhaust gas is used to rotate this turbine with the help of this fan. So exhaust gases are used to rotate this, and after that they go out in the atmosphere. Now what happens? On the other side you have the turbine. So what turbine does? Now since the turbine is moving, it will suck the fresh air from outside, right? So fresh ambient air inlet happens, and this compresses the fresh air. And again, like I said in the beginning, when you compress anything, it gets hot, right? So if it gets hot, the density goes down. So if I need to increase the density, what I have to do is I have to cool it down. So that is where the intercooler comes into play. Now this highly dense compressed air, which has lost some of its density because of getting hot, now that is pushed through the intercooler, which cools it down, increases the density of the air, and then pushes it inside the cylinder. So now instead of the normal atmospheric pressure air, you have highly dense compressed air inside the cylinder. Now to burn anything, you need more of oxygen. Burning of anything depends upon the quality of oxygen. So if you have highly compressed oxygen inside the cylinder, and now you put the spark, what will happen? It will be very heavy blast. So the power of an engine depends upon the blast. So if there is a heavy blast, what will happen? It will increase, it will give you more power. It will give engine the more power. And there will be better burning also. So that will reduce the pollution as well as give you more power. Right? So that is the benefit of introducing the turbocharging. So sometimes you will see that a 1 liter turbocharged engine giving power which is equivalent to a 1.5 liter engine. That's the beauty of turbocharging. I told you about the intake manifold, right? When I was talking about fuel injectors. So here in this picture, you can see the intake manifold, right? In intake manifold, it is connected on the other side with the air filter. So from air filter, the filtered air comes into this, the atmospheric pressure air. It is not turbocharged, right? So it comes here and it is there inside the intake manifold. And in every cylinder, for every cylinder, there is a pipe going, right? So the air is already there, and as and when the intake valve opens, there will be fuel will be injected through the injectors, and from the valve the air fuel mixture will be going inside. So that is how the intake manifold works. Similarly, there is an exhaust manifold also. So when the exhaust valve opens, the exhaust gases will go out through the exhaust manifold. From exhaust manifold, actually they go to the catalytic converter, and from there they go to the silencer, and that is how they are sent out. So the key terms that we use in an engine are RPM. RPM is revolution per minute. They are measured at the crankshaft. Then second is cubic centimeter, cc. We say na 1500 cc engine or 1.5 liter engine. So 1.5 liter or 1500 cc is the same thing, right? So that is engine displacement. Engine displacement is measured on all the four cylinders combined, right? So compression ratio, there's a ratio between bottom dead center and top dead center, right? So in a cylinder you have a piston. So the piston is going up to this level and coming down up to this level. So this is bottom dead center and this is the top dead center, right? So what happens? There is a air fuel mixture between this BDC and TDC, which is compressed to TDC. From BDC, the compression has happened up to TDC. So this is called as compression ratio, right? So compression ratio in petrol engines range from 12 is to 1 to, in fact, 8 is to 1 to 12 is to 1. Nowadays we have 12 is to 1. And in diesel engine, it goes up to 25 is to 1. And that is why the diesel engines are more heavier. They make more of noise, right? So that's the beauty of compression ratio. And to understand compression ratio, I give a very common example. How many of you have blown up crackers during Diwali? And how many of you have tried to do this mischief of opening unburnt or unburst crackers and taking out the that material from inside and packing it in a paper and burning it? What happens when you burn it like that? It will suddenly catch fire. It will make some buck kind of noise and it goes off. And a part of it tightly packed in a cracker, just try to understand how much of noise that and how much of energy it releases. Why? Because it was highly compressed inside that. So compression ratio actually increases the power of the same amount of fuel, but if you increase the compression ratio, it will generate more of power. But yes, both the engines have their own restrictions also. If you compress more in petrol engine, it might catch fire before the spark happens, just because of that heat. That can happen even in petrol also. So what will happen? There will be knocking, right? So all the engines are made keeping all the characteristic of their fuel and various aspects in mind. Then we have overhead valves. So overhead valves, all the engines have overhead valves only in the head of the engine. Then we have a single overhead camshaft. There are manufacturers who are still using single overhead camshaft, but most of the manufacturers have switched over to dual overhead camshaft. Like we saw in the earlier slides, that camshaft is used for opening and closing of the valves. So in single overhead camshaft, the intake and exhaust valves are opened by one camshaft. There's a one camshaft which opens and closes the valves intake as well as the exhaust valves. Whereas in DOHC, there are separate cams for intake and exhaust both. That's why they are called as dual overhead camshaft. Then the bore. You have seen that cylinder, that circle, that round hole inside, that is called as bore. That is the diameter of the cylinder. Then stroke, the distance the piston travels, TDC to BDC, that is one stroke. Then VVT, variable valve timing. It's a very interesting feature, you know. To understand this, I'll give you another very common example. You are walking on the road, a normal speed, walking. We can easily breathe from nose. We don't have any challenge breathing from nose. But what happens when you start running? You start panting, you start breathing from mouth also, right? Now the challenge with engine has food as well as breath both from valves. Engine mouth and nose both are valves. One feature, both the function. Having food as well as breathing. Both functions are done by the valve. So now you are moving your car at a speed of say 40-50 kilometers per hour, and now you increase the speed of the car by say 100-120. Don't you think the same condition has happened here also? Like you were walking and then you started running. Now, when you started running or when you press the accelerator, you started moving the car at a speed of 100-120. What will happen? Now the car needs more of fuel as well as more of air. But the valve opens and closes because of the movement of camshaft. The higher the speed, the faster the valves are opening and closing. So the amount of air and fuel mixture required is not going inside the cylinder. That actually reduces the performance of the engine at high speed. That's why if you look at speedometer of especially two-wheelers, now most of the four-wheelers have VVT, so there you won't find this, but in two-wheelers you will find that after say about 60-65, they must have marked red, and before that it is green or blue, economy. And from here the economy goes down. Why? Because your fuel is getting wasted, it's not being used. You are pressing the accelerator, the fuel is going, but it is not able to enter inside the cylinder because the valve is closing and opening very fast. Now see, you are moving the car at a speed of 40-50 kilometer. So your valve opening and closing time is suppose this. And now you have increased the speed from 100-120. Now the valve is opening and closing like this. So now the time has gone less, but you need more of food and air. So for that, we have a technology called as variable valve timing. What it does, it actually, there are two types of technology. One is known as cam changing. The other is called as cam phasing. Right? Cam changing and cam phasing. Cam changing is easier to understand. So here what we have the normal size cams, and then there is a bigger oversized cam in between these normal size cams. So after a certain speed, what happens? There's a lock in between. So now this lock happens, and now the valve open and close because of that oversized cam. That actually leads to your valve opening for a bit of extra time, and it remains open for more of time. That helps in increasing the air fuel mixture going inside. That maintains the fuel efficiency and performance of an engine even at higher speed. That's the benefit of BVT. The next module we will be talking about fuel system and air intake, because fuel system and air intake system, they are lifeline of any automobile. So see you in the next module.